Hello there, Mr. Sutton here, bringing you the Algebra 2 4-8 Part 1 homework solutions on analyzing graphs of polynomials. For this first problem, we're trying to graph this function that's in intercept form. So let's start by finding the zeros. Those are some easy points. If we zero out each of these factors, we end up with x equals 2 and -1. And next, let's take a look at the end behavior. So we have an x squared times an x and a positive out in front. So this is a positive x to an odd power. So that means that we have an upline sort of end behavior. And then one other piece of information, we've got two zeros here, so let's find a point in between those. I think 0 is a pretty easy number to plug in. So if I just plug 0 in for all the x's, that's going to be -2 squared, which is 4, times 1, so 4 when the dust settles there. So let me put all this on a graph now. We have -1 for the first x-intercept, then we had 0, 4, that's the point we just found, and then we have 2, 0 over here. Now our end behavior says that we're starting low and ending high. So we're going to start below the x-axis, go through this point, then come back down, and for ending we're going to have to bounce here to be ending high. So that's the way this one's going to work out. To graph this function, let's first find the x-intercepts, or zeros. Zeroing out each of these parentheses, we have x equals -2 and -4. Now the end behavior, we're going to have a positive, and this is basically an x squared and another x squared times each other. So this comes out to x to the 4th, an even number. This is a positive x to an even power. So this is an up parabola kind of end behavior, starting high and ending high. The last thing we need is a number between the zeros here to get a feel for what the function's doing in there. So I'm going to pick -3, that's right between those. If I plug -3 into my function, -3 plus 2 is -1. Squaring that just gives us 1, so we can kind of forget about it. -3 plus 4 is also going to be 1 before and after I square it, actually. So we basically have 1 times 1, or just 1. So getting my graph, I've got my x-intercept of -4. We have -3, 1 that we just found. And we've got -2, the other x-intercept. And we said that we're going to be starting high, so above the x-axis, and also ending above the x-axis. So we're going to come down here. That means we're going to have to bounce off of this point, and we're going to have to bounce off of this one to be ending above the x-axis as well. To graph this function, let me first find some x-intercepts. So zeroing out each of these factors, we've got x equals -1, +1, and then 3 minus 3 also zeros that out. For our end behavior, we have a positive. This is going to be an x squared times an x times an x. So that's a grand total of x to the 4th. So we have a positive x to the 4th, positive x to an even power for our lead term, basically. This is an up parabola sort of situation. And we also want to figure out a few points in between these zeros. So a point between -1 and 1, I bet if I plug 0 in, that'll be pretty easy. So that would give me 1 squared times -1 times -3. That would be a grand total of 3. And then a point between 1 and 3, if I plug in 2, that should do that one. So we've got 2 plus 1 is 3, squared is 9. And then this is going to be, let's see, 2 minus 1 is 1, 2 minus 3 is -1. So this is going to be -9 when the dust settles. Let's go ahead and graph it now. So we have our x-intercept of -1, that's our first point. Then we had 0, 3. We have an x-intercept of 1. 2, -9 will be down here. And then we have 3, 0 right there. Now we're starting above the x-axis and ending above the x-axis according to our end behavior here. So starting up here, we're going to have to bounce to go through that point, and then we're going to have to go through this x-intercept to get to this point, and then coming up here and ending above the x-axis. To graph this function, let's first get our x-intercepts, since this is in intercept form. So we have -1, -2, and we've got 1 for this last factor. Let's also figure out the end behavior. We have a positive out in front, basically x times x times x. So we have a positive x to an odd power, positive x to the third. This means it's going to be an upline sort of end behavior. And let's also get a few things in between the zeros here. So we need something in between -1 and -2. I think -1.5 will work as well as anything. I'm going to plug that in on Desmos. So let me enter my function in here because I'm going to use it a few times. So we got x plus 1, x plus 2, x minus 1. And we'll do g of -1.5. Comes out to 2.5. And let's also do 0. That's an easy one between -2 and 1. I could probably do that without a calculator, but if I've already got this loaded up, might as well, just to make sure I don't mess up. So -8, 0, -8. So we've got -2 is our first 0 here. And then we've got -1.5 comma 2.5 about here. And then we have -1, another 0. Let's see, we have 0 comma -8. And then finally we have the x-intercept 1 up here. So we're starting below the x-axis, ending above it. So starting down here, we're going through this x-intercept to get to this point, coming back down through this one, and going back up through this one to be ending above the x-axis. For this problem, they want us to graph the g function with some technology and then do a bunch of analysis. Let's go first and put this on Desmos and see what it looks like. So here we are on Desmos. I'm going to just put the g function in here. Let's see here, that's going to be 2x cubed plus 8x squared minus 3. And then let's move this so I can see it. Zoom out a little bit. There we go. So based on what I know with turnarounds, I know that I'm going to have at most one less turnaround than the degree. This is third power, so I'm expecting 2 turnarounds, and here they are. Since it's third power, I'm also expecting at most 3 x-intercepts, and here they are. So this tells me that I see everything I need to see on the picture. At this point, let me just click on some of those crucial spots. So here are the x-intercepts. And also, here are these turnaround spots that I'm going to analyze. And then let me just cut and paste that into my PowerPoint here so I can look at it without flipping back and forth between Desmos. So let's do x-intercepts first. That's going to be -3.9 and some change. I'm going 2 decimals, it looks like here. And then we have another one at -0.67. And then finally another one at, this is 0.57. Next up, let's do maxes, if any. We see that we have a local max up here at -2.67, 15.96. We also have a local min down here at 0, -3. And we also want to analyze increasing versus decreasing. So increasing, places where our graph is going up, that's going to be everywhere that's less than our max at -2.67. So x less than -2.67 is one interval where we are increasing. And there's this other interval for everything after that local min at 0, -3. So I'm going to write or x greater than 0. Now for decreasing, there's just this one stretch in here where x is between -2.67 and positive, or not positive, just 0. So between -2.67 and 0, that's decreasing. So basically everywhere that we're not increasing. On this problem, they want us to analyze the h of x function using some technology. So let's go to Desmos and graph this one out. So here I am on Desmos. Let's do h of x equals x to the 4th minus 3x squared plus x. And let's move this up so I can see it. Now in terms of turnarounds, since this is x to the 4th, I'm expecting at most 3 turnarounds. And I only see, let's see, we got 1, 2, 3 actually. So all 3 are accounted for. And we're also expecting at most 4 x-intercepts since this is x to the 4th. Let me zoom in and let me zoom out first and make sure there's nothing hiding anywhere. Nope. So let me zoom in now and see how many x-intercepts we actually have because it's kind of hard to tell. We've got 1 here. We've got another one closer in at the origin, and another one here, and another here. So that's 4. That accounts for all of those. And then we also have our turnarounds. We've got one down here, one right there, and one over there. So I'm going to cut and paste all of this stuff with all of these things kind of locked into place. So here is a graph of everything. This is a little bit tricky to read because there's a lot going on with this one, but let's give it a shot. So for x-intercepts rounding to 2 decimal places going from left to right, we've got negative 1.88. Next up we have the origin 0, 0. And we also have, let's see, a little bit further along we have let's see, this one right here, 0.35 is this x-intercept. This 0.17 here is referring to the max. We'll get there in a sec. And then finally, over here at the end at 1.53, that is our 4th x-intercept. Now for local maxes, here's our local max, 0.17, 0.08. For local mins, there's 2 of them. One of them's at negative 1.30, negative 3.51. And we have another local min over here at 1.13, negative 1.07. For the increasing intervals, we're increasing in a few spots. We're increasing from negative 1.30 until we get to this 0.17. So that's one increasing interval. And also we're increasing for all x values greater than 1.13. For the decreasing, it's all the other places. So x less than negative 1.30, this interval here. And also we're decreasing on this little stretch between 0.17 and 0.113. And I think that covers everything.